Imagine you're looking at high-resolution satellite images of Mars. Craters, dunes, ridges. All perfectly ordinary. Until one day an artificial intelligence program flags something impossible. A pyramid-shaped formation in the Cydonia region showing exact mathematical ratios. Not just any ratios, the same 60-based counting system invented by ancient Sumerians more than 5,000 years ago. This isn't a tabloid headline. This is real data flagged by algorithms built for orbital mapping. The patterns aren't random. They repeat across multiple Martian features. And now, with SpaceX preparing to send Starship missions to the Red Planet, scientists and engineers are asking a question that sounds like science fiction. Are we seeing echoes of cosmic mathematics on Mars? Stay with me as we break down what was actually discovered, why it's shaking up ideas about early civilizations, and what Starship might reveal when humans finally reach these formations. This isn't about wild conspiracies. This is about patterns that shouldn't exist, but do. Modern Mars orbiters collect an ocean of data: laser altimetry, high-resolution stereo imaging, infrared maps, and elevation grids accurate to within meters. Traditionally, planetary geologists sift through these images manually. But with so much terrain to cover, researchers increasingly rely on machine learning algorithms to spot unusual shapes. Think of it like facial recognition, but for landscapes. The program looks for geometry, angles, spacing, elevation ratios, then cross-checks that data against massive pattern libraries. These libraries don't just hold geological templates. They also include mathematical frameworks from Earth's ancient cultures. So when an AI flagged the Cydonia region, the alert didn't come from a human imagination. It came from statistical anomalies, terraces, ridges, and slopes lined up in ways that natural erosion rarely produces. Why is the number 60 such a big deal? Because the Sumerians, the world's first known urban civilization, invented a sexagesimal math system, base 60. They divided circles into 360 degrees. They counted time in 60-second minutes and 60-minute hours. Their temples, ziggurats, and astronomical tables all reflect this framework. These weren't vague resemblances. Independent algorithms produced identical results. Red team mathematicians checked by hand and confirmed the statistical significance. With each verification step, the confidence level went up. Picture a city laid out in blocks. Streets align in a grid, but imagine those blocks tilted at perfect 60-degree angles. That's what the Cydonia ridges look like in the data, not random, but ordered. And that's why the AI took notice. In Cydonia, the mathematical relationships persist through all of these tests. When the same methods are applied to random terrain, the correlations vanish. Feature filtering techniques, like noise-canceling headphones for geological data, actually strengthen the signal by removing distortions from wind erosion or impact craters. Ground-penetrating radar plus orbital imaging has revealed unknown pyramid complexes in Egypt and Guatemala. The math behind these algorithms doesn't care whether it's scanning limestone or basalt. If a structure exhibits certain geometric relationships, the software will flag it. Architectural convergence suggests that some geometric principles are universal, whether driven by physics, aesthetics, or astronomy. That's why a Martian formation echoing the same math is so intriguing. It might represent natural processes mimicking those principles, or something we don't yet understand. Here's where the story turns from data to exploration. For decades, the Cydonia region has been off-limits to human eyes. All we've had are images. But with SpaceX's Starship system gearing up for interplanetary missions, physical exploration of these sites is moving from science fiction to engineering reality. Starship's heavy lift capacity means it can deliver rovers, drilling rigs, and crewed habitats directly to scientifically interesting regions. High-resolution imaging from orbit is powerful, but nothing beats boots, or wheels, on the ground. Instruments could test rock samples, measure isotopic ratios, and determine whether the terraces are purely geological or something else entirely. Skeptics argue that humans are pattern-seeking creatures. We see faces in clouds, animals in constellations. That's true. But AI doesn't see in the same way. It calculates. And when two independent systems using different math reach the same conclusion, the odds of pure coincidence shrink dramatically. A quick clarification for viewers: in this context, match doesn't mean message. It means pattern correlation. Think of a fingerprint match in digital security. Two prints might look similar, but algorithms compare dozens of tiny metrics, ridge spacing, angles, minutiae, before declaring a match. Similarly, the Martian analysis compares multiple mathematical properties, angles, ratios, spacing, not just one. Only when enough of these properties line up does the system flag a significant correlation. This is why we make videos like this, to dig past the headlines and look at the actual data. Not to push conspiracy, but to explore possibilities. Artificial intelligence is giving us a new lens on old mysteries. It's finding fingerprints of order in places we never thought to look. Whether those fingerprints belong to nature, mathematics, or something else entirely is the journey ahead. If you want more breakdowns like this, where we unpack how science, technology, and history intersect on other worlds, subscribe to the channel. It helps us keep digging. So, what do you think? Are we glimpsing universal mathematical patterns, or is this all just an extraordinary case of nature imitating design? Either way, the Cydonia formations have gone from curiosity to priority target. When the first Starship missions land on Mars, this region may finally reveal its secrets, and possibly change everything we thought we knew about our place in the cosmos. Thank you for watching my channel.